My dear students, in this session I am going to discuss line or axis of symmetry. In the previous class we understood the meaning of symmetry and various symmetry elements, and we also understood center of symmetry. So now line or axis of symmetry. Line or axis of symmetry means it's an imaginary line. It is passes through the crystal on rotating crystal about that axis or line, so it presents the same appearance more than once during the course of a complete rotation or 360-degree rotation. This is called as line or axis of symmetry. There are three types of axis of symmetry. So the one is axis of twofold symmetry, axis of threefold symmetry, axis of fourfold symmetry, or we can also call as fourfold axis of symmetry, threefold axis of symmetry, like that. So now let us see one by one. The first one is axis of twofold symmetry. In case of axis of twofold symmetry, so as I said in the beginning, we can pass the line or axis through a cubic crystal in three different ways. So one is through two opposite faces, and second one is to two opposite corners and two opposite edges. So in case of axis of twofold symmetry, we are going to pass the line between two opposite between two opposite edges. You observe here. So two opposite. So for example, the opposite edge for this is, so this is this two opposite edges. So this one, and so two, these are the points of intersection of two opposite edges. So like this. So when we come to a cubic crystal unit cell, there are 12 edges are there. So totally six type of axes are possible. So totally there are 12 edges, and so by using 12 edges we can write six different axes through so these 12 edges. So dear student, it's very important. So there are 12 edges. So I am going to pass the line so between the opposite forces, opposite edges. So center of two opposite. So this is corner, and this is face, and this is an edge. So there are 12 edges in a cubic crystal. So I am going to pass the line between two opposite edges. So this is two opposite edges. So then on rotating the line, so on and rotating this crystal on this line, at that moment the same appearance appeared twice. That's why it is called as twofold axis of symmetry. That means if you rotate this line along this axis, that axis which is passes between two opposite edges. Dear student, this line, the line and it is passing in a particular position in a unit cell. It is very important. If you really understood the exact location in which the line is passing, you can easily understand this concept. So better you can understand, dear students, you take one cube and you do all these operation. So then you can easily understand all these things. So take a cube and take one stick and small stick and make a hole so through the opposite edges, and just pass that stick through opposite edges, and so then rotate that cube. So by keeping stick as a constant, at that moment you can observe the same appearance so two times. So that's why it is called as twofold axis of symmetry. So totally in a unit cell there are 12 edges. So six such different axes are possible. So that's why in a cubic crystal, so there are 12 edges and six diagonally opposite pair of edges in a cubic cell is possible. So totally so 6 different type of operations there are. So in twofold, there are 6 twofold axes of symmetry operations are possible in case of a cubic crystal. So you have to know how it is twofold. That means twofold are just rotating. You are going the image appearance 2 times. That's why it is twofold. So there are 6 twofold axes of symmetry is possible in case of a cubic crystal. Why 6? Because there are 12 edges and we can draw 6 such a diagonal line which is passes through the opposite edges in a crystal. That's why 6 different 6 twofold axes of symmetry is possible in this case. The next one is axis of threefold symmetry or threefold axis of symmetry. Let us consider a cube in which, so in order to obtain threefold axis of symmetry, the line must be passes between two opposite corners. So this is called as body diagonal, which is passes through the body. It must be passes through two opposite corners, dear students, not on edge. So in the previous case we discussed the line which is passes between the center of edge, but in case of threefold symmetry, the line which is passes through two opposite corners. So there are 8 corners in a cube. So totally we can write 4 such line, because for 2 points we can write one line. So there are 8 such points, 8 such corners are present in a cube. So totally we can write 4 lines. So they are, so between these 2 points we can draw the line, and between these 2 points it's a third line, and the next line is, so between these 2 points, between these 2 points we can draw the line. So totally we can draw the 4 line. Then on rotating this crystal in any one of the line at that moment, so we are going to obtain the same appearance 3 times. So same appearance obtained 3 times. That's why it is called as threefold axis of symmetry. So in case of a cubic crystal, as I said, there are 8 corners and 4 such body diagonal line. It is passes through two opposite, dear students. Here the line, so for example, if you consider a cube, okay, this is one, okay, corner, this is one corner. Suppose if the line is passing through this, so this is not body diagonal, it's a face diagonal. But you observe here, in this case it is passes between exactly two opposing corners, so it is passes through the body. But in this case what happened, for example, you consider this line, this is also passes between two corners, but not two opposite corner, it is passes through the face. So you should not consider face diagonal here, it must be passes through the two opposite corners. So it is diagonal, body diagonal. So there are 4 such body diagonals are possible. So that's why you can rotate the crystal in by using 4 axes. So 1, 2, 3 and 4. By using 4 axes you can rotate this crystal, and after rotating you can get so 3 same appearance 3 times. That's why, so there are 4 operations there. They don't get confused between threefold axis and 4 different operations. Why it is called as threefold? Because so on rotating we have got same appearance 3 times. So for one complete rotation we are counting this for one complete rotation, that is for 360 degree. So we have got so 3 times the same appearance obtained 3 times, that why it is threefold. So in case of cubic crystal there are 8 corners and totally 4 lines are possible, body diagonal lines are possible, which is passes through opposite pairs of corners. So totally 4 such axis of symmetry operations are possible in case of so threefold symmetry. There are 4 threefold axis of symmetry is possible. Next one is axis of fourfold symmetry. Fourfold symmetry means So here also we are going to passing the line or axis through the crystal, and we are allow the crystal to rotate about their axis, and so thereafter we have got the same appearance four times. That's why it is called as fourfold axis of symmetry. So if you consider this cube, so we can pass. So in case of fourfold axis, the line which is passes through the center of two faces. So it passes through center of two opposing faces. So in the previous case, it is passes through corners and edges. In case of twofold, it is passes through an edges, and in case of threefold, it is passes through the corners. But in case of a fourfold symmetry, it is passes through two opposite faces, dear students. So face, corners, face, so corners and edges, don't get confused. There are six faces are there in a cubic crystal. So totally there are three such axes are possible along three directions. So this is one line, then second line is, so this is a second line, and this is a third line. So it is passes between, for example, there are six faces. So 1, 2, 3, 4, and so 1, 2, 3, 4. So this face is, this is the fifth face, fifth, sixth. There are six faces are possible, and three such lines are possible. Then if you rotate the crystal along the first line, for example, if you rotate along, if you rotate the crystal along the first line, at that moment the same appearance obtained four times. For example, if you rotate like this, so this is the first appearance, this is the second one, and this is the third phase, and this is the fourth phase. Okay, in a cubic crystal, all the faces having same area. That's why same appearance obtained four times during a complete rotation of this cube along this axis. So that's why this is called as fourfold axis of symmetry. In case of a cubic crystal, there are six faces and three pairs of opposite lines are possible. So totally there are three different fourfold axis of symmetry is possible in case of a cubic crystal. So this is about axis of symmetry. So we understood twofold axis of symmetry, threefold axis of symmetry, and fourfold. Dear student, in order to understand clearly, you must know the axis in which is passing through the unit cell. Either it is through a corner, either it is through corners, either it is through, this is a corner, or either it is, sorry, this is the corner and this is the edge or face. So based on the position from where the line is passing, we are classify the axis of symmetry into three types: twofold, threefold, and fourfold axis of symmetry. So in the next class, I am going to discuss the third type of symmetry operation is plane of symmetry. So far we completed. So there are three kinds of symmetry operations. So one is center of symmetry and axis of symmetry. The last one is plane of symmetry that I am going to discuss in the next video.